Algebra 1, factor polynomials, focusing on quadratic trinomials where a equals 1. We're going to continue looking at how to factor polynomials and the process that we started in the last concept and just continue with that process. So the first thing is you want to get down a couple definitions. Remember, pause the video if you need to. So the first definition is we're going to use what's called the zero product property in this section. It's just a logical thought, mathematical thought, that if the product of two factors, so you're multiplying two things together, is 0, then one or both of them must equal 0. And we're going to use that idea to help us solve quadratics once we have them factored. Then the next definition is a solution or solutions of a quadratic equation, because we're going to be solving quadratic equation. Those are the value or values of x when y equals 0 in a quadratic equation. Also, under this definition, I want you to write down the standard form for a quadratic equation just to get it in your mind. So the standard form is ax squared plus bx plus c. Now that is where a, b, and c are constants, are number values. And then x, of course, is your variable. All right, let's review the process of factoring polynomials that you learned in the last concept and then look at the next part that we're adding to it. So step 1, remember that what we're looking for is any greatest common factors, numbers or variables, that we can start and factor out of the polynomial. Then step 2, we're focusing on the number of terms in the polynomial or the remaining polynomial that we have, because the terms will tell us how to look and factor. So if we have two terms, we're going to look for a special factoring pattern, which is called a difference of squares. Now, what we're doing new in this concept is if we have three terms, then we're going to look and see if we have a polynomial in quadratic form, which is what we just talked about, and do a quadratic factoring method called the grouping method. So again, something in quadratic form would be a polynomial that we could arrange ax squared plus bx plus c. Now, if you do end up with a trinomial, and it is in the quadratic form, the ax squared plus bx plus c, this is the grouping method. So I'm going to go through these steps with you. And at first it will seem kind of cumbersome, but then it will get easier the more that you do this. So we're going to start with the trinomial x squared plus 8x plus 12. And notice that this is actually an equation. It says equals 0. So after we factor it, we're going to solve. We're going to find the solutions, if it has any, and that's the value of x when y equals 0. And y does equal 0 here. So the first step in grouping is that we want to work backwards and try to find what was multiplied together in the two binomials to get this trinomial. So the process is we're looking for two numbers that will multiply to give you a times c and add to give you b. So right above, I'm just going to remind myself that this number 1 is a, 8 is b, and 12 is c. I'm going to create a little workspace over here, and I'm just going to draw my line. I'm also going to create a graphic organizer for myself, just an x. I'm going to call it the x factor, because it's going to help me factor this. So two numbers that multiply to give me a times c. So I'm going to write a times c, 1 times 12 is 12. And that will add together to give me b. So I'm going to put this number below. Nothing magical, just helping me organize. Now I think about two numbers that I'll multiply to give me 12 and add at the same time to give me 8. 1 and 12 doesn't work. Then 2 and 6, yes, 2 and 6. So I've just done step 1. Now step 2 is I'm going to rewrite the middle term of the quadratic as the sum of those two numbers, because I can. So I'm going to rewrite my quadratic, and then x squared. Now I'm going to split up 8x into, using my 2 and the 6, so they're positive, so they'll be connected with addition signs. I'm going to bring down the rest of my equation. Okay, step 2. Now, step 3, I'm going to group the first and the last two terms together. I'm going to group them by simply just drawing a dividing line right after the second term, right there. Okay? Then I'm going to factor out any greatest common factors, you know what they are now, of these grouped terms. So the first, x squared and 2x, my common factor is a single x. I'm going to do just like I've done before and write what I have left in the parentheses. Now I look at the next two terms, 6x and 12, and I can factor out a 6. So I'm going to keep that sign, positive 6, open my parentheses, and what I'll have left is x plus 2. Now I still want you to think of these as kind of two sections, all right? And we're now going to, we've just done step 3, we're going to factor out any common expressions in those two parts. Well, if you see, we've got an x plus 2 in the first part and an x plus 2 in the second part. So that entire expression can be factored out to the front. So I'm going to write it here. And then what I have left is just this simple x. So I write my parentheses, draw parentheses, and then write what I have left, plus 6. So now what I've got is my binomials. If I multiply these together, I get what I started with. Now our very last step is to continue and solve. So we have the equals 0. Now that zero product property rule says if you have two things multiplying together, well we do, this one and that one, equaling 0, one or both need to equal 0. So we're just going to say, oh, let's say both of them do. So we're going to set up two equations where they both equal 0. Whoops, let's try that again. So x plus 2 equals 0, x plus 6 equals 0, and then we'll solve. So our two solutions, what x is when y is 0, subtract 6, are x equals negative 2, and x equals negative 6. If I plotted these would be my x-intercepts. Now I know this process is a lot when you first learn it, but soon you'll get really good at it. So let's look at the next example. So we've got x squared minus 7x plus 12. Now notice all we're doing is factoring here. We don't have the equal sign and we don't have to solve, do that final step. So we're just going to factor it down into the two things that we multiply to get that. So I go through my process. First step is I look for a greatest common factor. But the only number that I'll divide into each of those terms, the a, b, and c, is a 1. So I don't need to factor that out. And we don't have common variables in each term. We do have x's in the first two terms, but not in the third. So there's no greatest common factor. I look at the number of terms, there are 3. So now I'm going to do my quadratic factoring, which is the grouping method. Okay, so if you want to keep your eyes on that step by step now under the grouping method. So we're looking for two numbers, so here's my workspace, that'll multiply to give us a times c. So 1 times 12 is 12. And we'll add together to give us negative 7. So we're taking that. So I think about factors of 12. So 1 and 12, 2 and 6, 3 and 4. And if they are both negative, when I multiply, I will get positive 12. And when I combine them, add them, negative 3 plus negative 4 is negative 7. So those are the numbers that I want. So now step 2, I'm going to rewrite my middle term, negative 7, using negative 3, and I'll place an x, and minus negative 4. All right, step 3, I'm going to group the first two terms and the last two, and I'm going to do that very simply by just drawing a dividing line. Now I'm going to focus on the first two terms, and I can factor out an x and I'll have x minus 3 left. My last two terms, if I have a negative in the front term, I go ahead and factor that out. So I can factor out a negative 4. And then if I divide negative 4, I'm left with a positive x. 12 divided by negative 4 is negative 3. Now again, continue to think in your mind of those divided into two parts, and you're going to look for a common expression. You should have one if it's factorable, which it is. So that's now what we're going to divide out or factor out to the front. We open a parentheses and write what we have left, which is just our single x term minus 4. Number 2, we're doing the same thing. We are factoring. So let's list our A, B, C terms. Step 1, looking for a greatest common factor. I don't see any common numbers or variables that I can factor out. Step 2, looking for my number of terms. There are 3, so we're going to try the factor by grouping. Now my workspace, I'm going to put it over to the left this time. So I want two numbers that I'll multiply to give me 1 times negative 12, and will combine to give me negative 11. Now if I have my signs right with the numbers 1 and 12, I can get those to be negative 11. So if I have positive 1 times a negative 12, that'll give me negative 12, and if I add those, I get negative 11. So I'll rewrite my middle term using 1 and negative 12. Now let's divide those. Okay, so the first two terms, x squared and just single x, I can factor out an x, and then what I have left is x and then just a 1 here. Now between negative 12, negative 12, I can factor out a negative 12. And then what I'll have left is x and a positive 1. So again, imagine our two parts. You're looking for a common expression now, which is x plus 1. So we can factor that out. And when we do, see we have left x minus 12. So we factored. On example 3, we're going to factor m squared minus 6m plus 9. M's work the same as the variable x's. And then part of the directions is to use the zero product property rule because we're going to go ahead and solve. These directions are just like some of the ones that you'll get when you do your Math Excel practice. And I try to do that in the notes, have problems that have the same directions as in your practice so that you can have your notes out when you're doing your practice to help you remember. So again, no greatest common factor. We have 3 terms, so we'll look to see if we can do factor by grouping. Our A value is 1, our B value is negative 6, and our C value is 9. So my workspace, two numbers that multiply to give me 1 times 9, that's A times C, and combine to give me negative 6. So I think of my factors of 9. I've got 1 and 9. If I add them, I get 10. Subtract them, I get 8. 3 and 3. Oh. And then I need them to be negative 6, so I'll make those both negative. If we multiply negative 3 by negative 3, we get positive 9. And if we add, we get negative 6. So we can split up our middle term with those two numbers and then group them together. Once we do that, then we're going to factor out a common factor. So we just have a common factor of m. And remember when the negative term is first, so this negative 3, we're going to factor out that negative. So we'll be left with positive m and then minus 3. So now we're still thinking of it in two parts. We're going to look for a common expression, which we've got. m minus 3, and that expression will get factored out. And then what we have left is m minus 3. Now our very last step is to set them equal to 0 and solve. If our expressions are the same, and sometimes they will be, you only need to set one of them equal to 0, because you're going to get the same thing. Alright, so our one solution is where m is 3. Now number 4, notice this is already factored for us, two things multiplying together. So all we need to do now is just set each of these equal to 0 and solve. So subtract your 9, add your 8. So sometimes you'll get polynomials that are already factored, so we just jump right to using our zero product property rule and solve. Now on number 5, we're going to factor and solve, but notice we do not have our quadratic in standard form. So we need it to be ax squared plus bx plus c, and then if we make that an equation, equals 0. So we need to subtract our 21 over. So the first thing is we'll write it in what we call standard form. So it'll be x squared plus 4x minus 21 equals 0. We don't have a greatest common factor. We have 3 terms, so we're going to look for our trinomial factor by grouping. So there's our A, B, and C. Okay, so I'm going to kind of move my workspace over here. So I want two numbers that will multiply to give me 1 times negative 21, and will add to give me 4. Now when I think of factors, I just ignore the negative. And I think, well, if I added or subtracted them. So if I added, I get 22, subtracted, I get 20. So, oh, here we go. If I subtracted 3 and 7, I would get 4. I need 1 to be negative, so I'm going to make my 3 negative. The reason is because when I multiply negative 3 times 7, I get negative 21, but when I add them, I get positive 4. Now you're going to start to notice that when our a value is 1, what we'll end up with is expressions where you'll just have your variable and then your first number that you found times your second. Okay? Now let's go ahead and do the grouping part, and you'll see that that's true. So you can start when your a value is 1 just by jumping right to the 2 sets of parentheses. So if we rewrite this, so negative 3x plus 7x minus 21, and then we'll split that in half. We'll factor out our x, and then between 7 and negative 21, we can factor out a 7 plus 7. So we'll be left with x minus 3. And then notice our common expression is x minus 3. And that's exactly what we had there. So now we just set those both equal to 0. So x minus 3 equals 0. So x equals 3. And then x plus 7 equals 0. So x equals negative 7. So number 6, notice we've got x squared equals negative 7x plus 44. It's like number 5 in that it is not in standard form. So the first thing we need to do is to move that 7x and the 44 over. So we'll just, do the opposite. So we'll end up with x squared. Let's try that again. So x squared plus 7x minus 44 equals 0. Alright, no greatest common factor. So we're going to look for quadratic factoring. There's our A, B, and C. So I'm looking for two numbers that, here's my workspace, multiply, I'm going to get this out of the way, to give me negative 44, whoops, and combine to give me positive 7. Alright, so 44, 1 and 44, no, if we add we get 45, subtract we get 43, 2 and 22, add we get 24, subtract we get 20, 3, 4, oh, 4 and 11. So if we subtracted, we'd get 7. So we want to make that 4 negative. Negative 4 and 11 was positive 7. So now we'll rewrite our 7 as negative 4x plus 11. So we're just rewriting it using those two terms. We'll just continue and finish. And now this is the grouping part. This is why it's called factor by grouping. Now remember that hint I gave you that if your A value here is 1, you're going to end up with your variable and your two numbers in your parentheses. So we'll just skip this middle part for this and know that when we have found our two numbers, we can go right to our two sets of parentheses. Then we want to solve. So we want to set those each equal to 0. So x minus 4 equal to 0, add to both sides, so x equals 4. And then x plus 11, subtract, so x equals negative 11. So those are our two solutions. Now work through the first 3 independent practice problems. Pause the video. Remember to move them into standard form if need be, and go through the factoring process using that factor by grouping. And then notice you're solving each one of them. So after you get it factored, set it equal to 0 and solve. So pause your video now, work through the first 3, and then come back and check your answers. Here are the solutions to numbers 1, 2, and 3. So when it was all factored and said and done, x equals negative 1, x equals negative 2 and positive 1, x equals positive 7 and negative 1. So pause the video and then look at my work, check your work, and make sure that you did it correctly, or if you didn't, that you can see where you went wrong. And here are the answers to numbers 4, 5, and 6. So for our solutions are 2 and negative 5. For number 5, our solutions are 5 and 1. And for number 6, our solutions are negative 10 and negative 2. Again, pause the video and look through my work and make sure that you understand how to do the process, factor, and then get the solutions, and then complete the Math Excel practice over this concept.